The plan for today is to look at the PowerPoints from the three sections that we have, 9.1, 9.2, and 9.3, and then I have some example problems to go over. I'll bring up the first PowerPoint. And the first one is going to be 9.1, and we're going to be looking at measuring length and focusing a little bit on the metric system, but also looking at the standard system. So in the standard system, kind of what we usually use in the United States, for measuring length, you're probably familiar with inches, feet, yards, and miles. So depending on how far of or how great the length is for smaller lengths, we would use inches. For longer lengths, like a distance traveling somewhere, we would use miles. And then we have all of these different conversion factors here. So a foot is 12 inches, 3 feet is a yard, and then 5,280 feet is a mile. So when we want to convert between these, one easy way is to think about taking units that we have and converting them by using what we call unit fractions, or I call them unit multipliers because we multiply by them. And so, for example, let's see what it would look like to use one of these. I have lost my tool. Hold on a second. There we go. Okay, so I have, say, 5 feet, and I want to convert it to inches. So I want to figure out how many inches is that? 5 feet is how many inches? So I'm converting from feet to inches. So I come down here and I find 2 unit multipliers that help me to convert. And how do I pick which one? The one that I pick is going to be the one that has the units that I want to convert to in the numerator. I want to convert 2 inches from feet. So that means I want the inches in the numerator and the feet in the denominator. And then because 12 inches and 1 foot are exactly equal to one another, multiplying by 12 inches over 1 foot is like multiplying by 1. So it doesn't change the value. It's only going to change the units. And remember that when I have a whole number, I can always write it as over 1, if that helps you to remember, because when we multiply fractions, we're going to multiply numerators and multiply denominators. So if it helps you, just put over 1 to remind you what's going to happen to your denominator. And then whenever we have the same units in any of the numerators that we're multiplying in any of the denominators, they cancel. So I can cancel feet in the numerator and feet in the denominator. And that leaves me with 5 times 12 over 1. And now my units are inches. That's what's left. And now all that's left to do is simplify 5 times 12 over 1. Well, 5 times 12 is 60. Divide that by 1. And we have 60 inches. 5 feet is exactly equal to 60 inches. And we can do similar problems depending on the units that we want. So the main thing that you want to remember is that your units that you are wanting to convert to need to be in the denominator of the fraction you choose, and the units you want to convert out of need to be in the denominator. So numerator, the units I want, denominator, the units that I'm converting from. Okay, and we did an example of that. Here's a couple of more examples. So converting 40 inches to feet. Now, in this case, I'm converting inches to feet, so I'm going to flip that fraction. And this time I want the feet in the numerator and the inches in the denominator. And then after I've canceled out my units, I'm going to multiply 40 times 1 and 1 times 12. So I have 40 over 12, which if I simplify that, it turns out to either 3 1/3 or 3.3. That bar means that those 3's go on forever. 3.3 feet. If I wanted to reduce that to the nearest tenth, then I would call it 3.3. And then instead of doing this, converting feet to miles, let's do an example if I wanted to convert 40 inches to yards, or just to make the arithmetic simpler, I'm going to convert 72 inches to yards. So, oh, I lost my, keep losing my, there we go. So I want, oops, I want 72 inches, and I want to know how many yards that is. So notice that this one is going to help me convert from inches to feet, but I want yards. So what I'm going to do is I'm going to first convert from inches to feet. So multiplying this one out is going to cancel my inches. And then I'm going to use the unit multiplier that has feet in the denominator and yards, which I want in the numerator. So in this way, I can combine two of those fractions. And remember that 3 feet is 1 yard. So now I can cancel out the feet. And let's see what I'm left with. I'm left with in the numerator 72 times 1 times 1. And my units are now yards. And in the denominator, I have 1 times 12 times 3, 36, which gives me 2 yards. So we can combine as many of these as we need to in order to get to the end result that we're interested in. So for simple problems, we're only using 1 unit multiplier. And then for more complex problems, we might need to use 2, 3, or more. For the metric system, and this is true for everything, not just length, but in the metric system, for each of the things that we measure, length, weight, volume, we have a base unit, and for length, it is the meter. Write that down. So the base unit is meter, and it's about a yard, or about 3 feet. Okay, so we have a meter, and then instead of having all these kind of weird, 3 yards is 3 feet is a yard and 12 inches is a foot, we actually have this standard base 10 system, which works really well. And we have all these different choices. So for example, 10 of our base units, 10 meters is a decameter, and 100 meters is a hectometer. Really, we only use kilo, centi, and milli. So we don't really need all of these, but we have them if we want to use them. But in reality, these are the main ones that you hear. So if I'm measuring something like, say, water or gasoline, if I'm measuring like a distance maybe within a building, like how wide a room is or something, I would probably use meters. Something much bigger, like distance from, say, my work to my home, I would use kilometers. And then something smaller, like, maybe the, the classic one for the millimeter is the thickness of a dime. Okay. So for something tiny where I want to be more precise, I'm going to use millimeters or centimeters. So even though we have all these different ways of doing it, we usually just stick to large measures, intermediate measures, and then small measures with centi and milli. And that goes for all of the things that we measure. But the beauty of it is that a kilo always means 1,000. So whether I'm measuring distance or weight, it's still going to be 1,000 of the base units is a kilometer in this case, and 1/100th of a base unit is going to be a centi or centimeter in this case. And so the beauty of that is converting is really easy, because what happens when I multiply by a power of 10? I just move the decimal point that many places, right? So multiplying by 100, that's 10 to the power of 2. So I move the decimal point 2 places, the same number of zeros that there are in the number, right? And when I'm going in this direction, I'm dividing, which is moving the decimal point in the other direction. So it makes it really easy converting between all of these. And here you can see what it looks like when we combine it with the meter. So kilometers, 1,000 meters, the meter, which is our base unit, which is about a yard, centimeter, there's about a couple of these in an inch, and then millimeter, 1,000th of a meter, and I always think the thickness of a dime if I want to kind of visualize about how big that is. So as I mentioned, changing is really simple. If I'm moving to smaller units, so I'm moving from kilometers to meters, I'm going to just move the decimal point 3 places to the right. If I'm moving from meters to kilometers, I'm moving 3 decimal places to the left. So for example, 504.7 meters, from meters to kilometers, there's 1,000 kilometers in a meter. A kilometer is a bigger unit of measure. So that means there's going to be less of them. So I move my decimal point 1, 2, 3 places. So it started out here. To get it 3 places over, it's going to become 0.5047, or about half a kilometer. Makes sense, right? If 1,000 meters is a kilometer, then 500-ish meters should be half a kilometer. Let's see what happens when we convert from meters to centimeters. So we have a larger unit, the meter, to a smaller unit, the centimeter. And it's 2 places over. There's 100 centimeters in a meter. So I'm just going to move the decimal point 1, 2 places to the right. So it started out here. In order to move it twice to the right, I'm going to add in 2 zeros, which tells me 27 meters is 2,700 or 2,700 centimeters. And then we have some conversion factors that we use when we're converting between the English system and the metric system. The exact units are that 1 inch is 2.54 centimeters and 1 foot is 3.48 centimeters. Some approximations that we use that are really helpful is that a yard is about 0.9 meters. So that's not exact, but it's a good estimate if you want to get an idea. And then a mile is about 1.6 kilometers. And you maybe also heard that a kilometer is about 0.6 miles. So you can kind of use those to get quick approximations. Now, when you're doing homework, quizzes, and exams for Math 125, you're going to want to make sure that you use those conversion factors that we posted in the announcements, because they're a little less precise than these exact ones. But we've come up with some of these useful approximations for getting those quick approximations of the conversion. So use those factors, otherwise your answers will be marked incorrect. So you don't want to be using, even though they're convenient in real life, you might want to use some of the tools that you can find on the internet to convert. When you're doing your homework, make sure that you're practicing and using these conversion factors. All right, so converting 125 miles to kilometer, I'm going to make sure that I use that conversion factor. 1 mile is 1.6 kilometers. So if I'm converting from miles, those need to be in the denominator, and the new units, kilometers, need to be in the numerator. And then remember, I can write 125 as 125 over 1 to remind me when I'm multiplying those fractions. And then notice that the miles in the numerator cancel with the miles in the denominator. So I have 125 times 1.6 kilometers, 200 kilometers, approximately. And if I wanted to convert from millimeters to inches, I have 26,800 millimeters. Then I'm going to use the conversion to convert my millimeters to centimeters. And remember, a millimeter is smaller than a centimeter, and it's smaller by a power of 10. So that means I'm just moving my decimal point once to the left. So 26,800 millimeters is 2,680 centimeters. Once I've done that conversion, now I can use this unit multiplier to convert from my inches to my centimeters. And another way of thinking about this problem, if you find it easier to think about this way, if you don't like just using the move the decimal point, is that you can always remember that 1 centimeter is 10 millimeters. And so then I can use 2 unit multipliers here. So I could have started with 26,800 over 1 millimeters. And then to convert to centimeters, I can use this one, 1 centimeter, what I want in the numerator, 10 millimeters in the denominator. And then I can multiply by my conversion factor, which converts from centimeters, which I put in the denominator, to inches in the numerator. And now I can cancel millimeters and centimeters. So this will accomplish the same thing that we did here. Just another way of thinking about doing that conversion from millimeters to centimeters. That's it for this section. Yep. Okay, I will start up our next section, which is going to be 9.2. And in 9.2, we're going to be looking at area and volume. And there's a very important thing to think about when you're converting area. So let's take a look. Here, notice that I have a square unit. And when we measure area, we're thinking like, if I'm measuring in inches, how many inches, squares that have an inch on all sides could I fit into that space? So that's what a measure of area means. It's a two-dimensional measure. So for example, a square inch looks like this, okay? And a square centimeter looks about like this, okay? So if I'm measuring an area in inches, how many of these little squares could I fill in that area with? Square centimeters, how many of these little squares? And that's what we mean by measuring area. So if I think about this area, and these are just generic square units, okay? So how many of these little squares fit into this area? 1, 2, 3, 4 by 1, 2, 3, so 12 square units. So when we have a simple shape like a rectangle, we can count how many of the squares go in each width and how many go in each length. So 3 times 4 to give us 12. So the area of a rectangle is always just length times width. Now, here's where it starts to get interesting. When I'm converting from a square foot to a square inch, what I can do is I can think about 1 foot is 12 inches. So if I break this up by 12 in each way, notice that a square inch isn't 12 times bigger than a square foot. It's 12 times 12 times bigger. So a square foot is 144 square inches. And then let's look at a square yard. If we take a square yard and we divide the yard up into 3 by 3, so the yard is 3 feet by 3 feet. So that you can see is 9 square feet. Interesting point of trivia. The carpet and flooring manufacturers kind of use this to their advantage. They used to measure those things by square yards a long time ago, but not that long ago because I remember it. They used to measure by the square yard. And as the prices went up, they said, let's start measuring by the square foot, and people will all of a sudden miraculously think that it's not as crazy expensive as it's gotten. So they kind of use that to their advantage because guess what? Now they're dividing that not by 3, but by 9. So it really seemed significantly less costly, even though it's more costly, obviously, than it was years ago. Main thing to remember here is that when you're converting areas, don't forget. So when I do these, a lot of times I will just kind of take, say I'm converting an area. In fact, let's see if there's one on our next slide. No. Well, then let's just do one. I'm going to go back. Okay. So for example, if I have a homework problem and maybe I'm asked to convert an area that is 9 inches by, let's say 18 inches, and I want to convert that area into square yards. I want to know what's the area in square yards. I should have gone the other way around. I'm going to say it's, yes, hold on. I'm going to rephrase that just to make the arithmetic a little bit simpler. Okay, so I have an area and it's, we're going to say 3 yards by 4 yards, okay? So we know what would be the area. Well, the area would be 3 times 4, which is 12 square yards, and we can write it like that for square yards. Now, if I want to convert that to, we'll just convert it to feet since it's simpler. So 12 square yards, how many square feet is that? Well, what I can do is I can come back to this original problem and go, oh, 3 yards. Well, that's 9 feet, right? Because a yard is 3 feet. So this is 9 feet. Now this side, 4 yards, is 12 feet. Okay. So in square feet, it's going to be 9 times 12, or 108 square feet. Okay. I didn't just multiply by 3, right? I have to multiply by 3 squared. Or, so lots of ways to think about it. You can think of multiplying by whatever the conversion factor is squared, or you can think of just converting your units first and then calculating the area. For some reason, I think this makes it a little bit more straightforward. But do whatever makes the most sense to you. That's always the best way to do it. Okay, so here are some conversion factors that you can use, or you can use some of those techniques that I showed you in the previous slide. So here's an example of how we might use this type of property. We see that the population of Wyoming is 578,759, which is like smaller than most major cities, right? That's the whole state. Wow. That's pretty dense. And the area of Wyoming is 97,814 square miles. So we can figure out the population density, which is just the population, 578,759 people, divided by the area, 97,814 square miles. So that says that in every square mile of area in Wyoming, there's only 5.9, about 6 people per square mile. Lots of space there. And then we have some English to metric equivalents for area. And again, you can use these, or you can always just, if I'm converting from square inches to square centimeters, I can first convert my dimensions to centimeters and then calculate the area. So I think that often makes a little more sense. And the next thing I wanted to talk about is measuring volume. So area is 2 dimensions, right? We have a length and a width. Volume, we have 3 dimensions. So think how much space there is in a box or in a pitcher. Okay. And so to measure space, we, instead of thinking about that square unit, now we're going to think about a cube. Okay. So a cubic inch would look like this. It's 1 inch by 1 inch by 1 inch. And a cubic centimeter would look like this, 1 centimeter by 1 centimeter by 1 centimeter. So significantly smaller now that we are making them cubes. So to measure volume, we just think how many cubes would it take to fill a particular space. So you can see in this example, this cube here, the bottom square is 3 by 3, and then there's a second square stacked on top of it. So it's 3 by 3 by 2. So I would need 18 of these little cubic units to fill it up. And what we do is we take this idea of capacity or of volume, and then we say how much fluid could an object of that size hold? And that's where we get capacity, which we also often call volume. So things like liquid are measured this way. And these are the units that we use in the US customary system. So if you're used to cooking or baking, you're probably used to a lot of these. So we have a cup, which is 8 fluid ounces, not to be confused with the ounce that we use for measuring weight. So usually, sometimes we don't write the fluid, but these are fluid ounces. And then we have a gallon, or actually, if you think about it, so yeah, they're kind of not in the right order. So a cup is 8 fluid ounces. And then if we have 2 cups, we call it a pint. 2 pints, we call it a quart. And this one, I remember there's 4 quarts in a gallon because there's 4 quarters in a dollar. Quart is a word for 4. So 4 quarts is a gallon, 4 quarters is a dollar. So if we use all of these conversion factors, we can see that a gallon is 128 fluid ounces. Oops. And then we can talk about the volume in cubic units. So if we have a cubic yard, we could put about 200 gallons into that. So here's how we can compare our cubic units with the amount of liquid they could hold, or what we call capacity. So we say 200 gallons is about 1 cubic yard. Another beauty of the metric system is that these all have really nice powers of 10, which you'll see. Actually, let's look at that here. So how do we measure capacity, or the amount of liquid something can hold in the metric system? Our base unit is the liter, and you've probably seen that soda is, and other juices and drinks are sold usually in liter or 2-liter quantities. A liter is about 1.06 quarts, so your 2-liter is basically a half gallon. It's kind of interesting that they sell milk by the gallon and the quart and the pint, but they sell a lot of other beverages by the liter. Okay, and again, we have all these kilo, hecto, deca, but the main ones for liters, we really only use liters and milliliters. I really haven't seen the other ones used much. So for large quantities, it's pretty much always liters, and for small quantities, we use the milliliter. So a liter is 1,000 milliliters. That's the main conversion factor you're going to want to remember for using the metric system. And then here's what I was telling you about, how we have this really nice a cubic centimeter. So if I take that little cube that has a centimeter for each of its dimensions, the amount of liquid it could hold is exactly 1 milliliter. So a cubic centimeter is a milliliter. And 1,000, it's also 1 cubic decameter, but usually we say 1,000 cubic centimeters is a liter. And a cubic meter is a kiloliter. And that's the end of that one. So let's move on to the third section, 9.3. And we're going to look at the last two things which we measure, which are weight and temperature. And weight is going to be very similar in the metric system to what we've seen with capacity and distance, but temperature is going to be different. So in our standard customary US system, we use the pound, and that should be an L, not an I. That's a typo there. So LB, and that looks weird, but it comes from the Latin. So I don't know why we use Latin abbreviation, but we do, and why we use OZ for ounces, but we do. So remember, this is different from that fluid ounce that we use for capacity. So 16 ounces is 1 pound, and then 2,000 pounds is 1 ton. And those are really the only, there's some other ones that people sometimes use, but these are the most common that we'll see. And in the metric system, our base unit is the gram, which you're probably familiar with. And then so large things like the weight of a human adult would be kilograms. And then small things like amounts of medicines, we usually use milligrams. So for weight, we pretty much use the kilogram, the gram, and the milligram. Okay, so again, converting 950 milligrams to grams, you can see that there are 1,000 milligrams in a gram. So since I'm converting from the smaller unit to the larger unit, I'm moving the decimal point 3 digits to the left. There's 3 zeros in 1,000, so 3 digits to the left. Or if you prefer, you can also think of this as using the unit multiplier, which remember I'm converting 950 milligrams, and I can write that as over 1. And I want to convert that from milligrams to grams. So I'm going to say there's 1 gram is 1,000 milligrams. So 950, let's first cancel our milligrams, 950 times 1 over 1 times 1,000 grams. And 950 over 1,000 is exactly 0.950 grams. So whichever way makes more sense to you. is the way to do that. And then we talked about a cubic centimeter having the capacity of a milliliter. And guess what? The weight of that milliliter of water is exactly 1 gram. So as I said, these all have very nice conversion factors from one to the other. Unlike the US system, not the same. And then here are some conversion factors that you'll use. So an ounce is about 28 grams and a pound is about 0.45 kilograms. Now, one that I often use is that kilogram is 2.2 pounds. So if you're used to that one, if you use that conversion factor, you're not always going to get the same answer that Canvas has for like your homework and such. So again, make sure that you use those conversion factors that were posted in the announcements. And if for any reason you don't have access to them, just shoot me an email, jane.keller@joyce.edu, and I will send it to you. And then we have the ton. Okay, so we talked about the ton was 2,000 pounds. And then we have a metric ton, okay, which is 0.9 of these standard tons. So spelled differently, which helps in different abbreviation, capital T, small t. In this class, we'll mostly focus on pounds, ounces, grams, and kilograms, because those are the things that we're mostly used to weighing. So converting, and this is really common in healthcare, right? Because healthcare likes to use kilograms to measure weight. So if, in a doctor's office, we step on the scale and our weight is in kilograms, and if we wonder, oh, I wonder what my weight is today, usually it would be the other way around, but let's say I weigh 160 pounds and I want to convert that to kilograms. So I'm going to use that unit multiplier and I want to convert from kilograms. So the 0.45 kilograms is my numerator. Nope, I want to convert to. See, I just said it without even thinking about it. I'm converting 2 kilograms. 2 goes in my numerator. The denominator is the units I'm converting from. So I'm just going to multiply 160 pounds. Again, I can write that over 1 to kind of remind me that I'm multiplying fractions. And then I'm going to write that unit multiplier. 0.45 kilograms is 1 pound. So this is just like multiplying by 1. It's only going to change the units, not the value. My pounds cancel. And I have 160 times 0.45 kilograms, which is 72 kilograms. And then we have temperature, and temperature is very different. Okay, there's a formula because temperature is measured differently. And we measure temperature based on, let's see, well, in the metric system, we use Celsius. And this is really nice because 0 degrees Celsius is the temperature at which water freezes. And then 100 degrees Celsius is the temperature at which water boils. So that kind of helps you visualize how warm and cool various temperatures are. Fahrenheit, if you grew up in the United States, you're used to that as well. And these are kind of some odd numbers because these were based on other things than water. But we usually relate it to water because we're familiar with how cold it needs to be for water to freeze and how warm it needs to be to boil. So water freezes at 32 degrees and boils at 212 degrees Fahrenheit. So in order to convert from one of these to the other, we have to use a linear equation. And we can use the fact that 32 degrees is the temperature at which water freezes to come up with this equation. So to convert, if I have Celsius, and well, really I can use either equation, but it's a little bit more straightforward. These are basically the same equation, but this one, we have solved it for Fahrenheit. So if I know the Celsius temperature, I can plug that in here where the C is, and I will calculate the Fahrenheit temperature. And then if I know the Fahrenheit temperature, then I'm going to plug it into here, and that will calculate Celsius for me. And these are standard equations. So here's an example. So if you see 37 degrees Celsius, you know, this is kind of a goofy little thing, but say you are in a country, you are used to the temperatures in the United States, you go to some other country and the forecast says 37 degrees Celsius. Is that going to be a nice day or a cold day or a hot day? So I can plug it into this formula here, and I just, where the C is, I'm just going to replace it with 37. So 9/5 times 37 plus 32, and you can see that's 98.6. So pretty warm day if it's 98.6. If we want to go the other direction, okay, so say I'm sending some information to a friend who's going to visit me from another country, and I want to give them an idea of the temperatures, and 70, they're not used to Fahrenheit, so I can convert that 77 degrees Fahrenheit to Celsius. So I'm going to use this other version of the formula. So I replace that F with 77. So 77 minus 32 is 45. And then 5/9 times 45 is 25. So 77 degrees Fahrenheit is 25 degrees Celsius. So it's like a great day. So 25 Celsius is the weather I'll be looking for if I decide to travel. Beautiful. We also have this Kelvin temperature, which if you've taken chemistry, you've probably, or I think physics, they also use it. And this is a little bit different, and we have what we call absolute zero. The coldest possible temperature at which there's no heat and all molecules stop moving. So at, we say, 32 degrees Fahrenheit or 0 degrees Celsius, the water molecules freeze and stop moving, right? This is any element or compound or, yeah, I'm not a chemist. It's been a while since I took chemistry, but that's your absolute zero. And we can convert. So if you need to convert from Celsius to Kelvin, here you go. 0 degrees Kelvin is equivalent to negative 273.15 Celsius. Very, very, very cold. All right, and so here's that comparison, which is kind of nice. You can see temperatures at which water boils, water freezes, and absolute zero. Nothing's happening. All right, so that's the end of the new material. And then what I wanted to look at now is a few example problems. So let me pull that up. Let's see, I think it's might be up. Nope. Okay. Here we go. Okay, and actually, let me I'm going to stop that for a quick second, and then I'm just going to bring up a whiteboard. Where is it? Okay, actually, we'll just do this because I'm not sure where that is. Thought I knew where it was. There we go. I'm just going to bring up this guy. Whoop. Make it a little bit bigger. And then where did my little annotate go? Oh, it's not doing what I wanted it to be. Sorry, little operator difficulty. Okay, there we go. Let's make this bigger so we have a lot of. Okay. All righty, so a couple of things that I noticed in last semester's assignments from this week that were problems that people struggled with a little bit. So one of the problems says, whoops, wrong one there, whoops. It says something like this: I ran 1,500 meters, you ran 1,500 yards in the same amount of time. So we ran for the same amount of time. I ran 1,500 meters, you ran 1,500 yards. Does it make sense? I'll just say true or false. You ran faster. So first I want to think about which one is further. Is it 1,500 meters or 1,500 yards? Well, a yard is about, remember from our slides, 0.9 meters. Okay. So if I ran a yard, I only ran 0.9 meters. So I'm running the meters and you're running the yards, okay? So you're running less of a distance, right? So let's just think about a single meter. If I run a meter, actually, I said that wrong. If this is a meter, then this is 0.9 meters, 1 meter, 0.9 meters, which is 1 yard. So the person who ran the meter ran further than the person who ran the yard. And the same would be true for the 1,500 meters, right? This would just be times 1,500. And this would just be times 1,500 of these. So in other words, I ran faster, right? If I cover more distance in the same amount of time, I ran faster. So this does not make sense, does it? Okay. So for a question like that, just kind of think, break it down step by step. What's the difference between a meter and a yard? And then the difference between a meter and a yard times 1,500, right? Since the number is the same there. The next question we have is when multiplying by a unit fraction, the unit of measure that needs to be introduced should be in the denominator. So let's think about if I wanted to convert 3 inches to yards. Well, what am I going to do? I'm going to multiply by a unit multiplier. And remember, 36 inches is 1 yard. So I want to cancel the inches. So those inches need to go here. And then the yard is going to need to go here so that my inches cancel. So which of the units is the one that I'm introducing? That's my new units, the yards, right? Did I put them in the denominator? No. I put those in the numerator. So this is false. So if you kind of think about solving, when you have these questions for me, these tend to be kind of confusing. So to break it down, I like to think about a problem and then see what I did and then answer it based on what I did. That helps me to kind of think through these types of problems. And then we have this one, dimensional analysis. Uses powers of 10 to convert from one unit to another. And so dimensional analysis, remember, is what we call it when we're converting from one unit to another unit. And we use those unit multipliers, right? So that's what we did in that last one. We were converting 3 yards to inches. Or maybe I did it the other way around. I don't remember what I did, but if I'm converting 3 yards to inches, I'm going to use that unit multiplier with yards in the denominator and inches in the numerator, right? And I don't see any powers of 10 in there. So I would say that is not true. Now, it could be true if I'm converting in the metric system, right? A lot of times in the metric system, most of the time in the metric system, I'm converting using powers of 10, but it doesn't have to be. I might even be converting from metric to standard system or within the standard system. So this is not always true. So that's what is wrong with that statement. And I think I have another one. Yes. No, actually, the next thing that I wanted to look at are a few problems from our discussion. So yes, I was going to look at some of these discussion questions. Just a couple. I'm going to move to the end so I don't accidentally do someone's problem. Let's see which one looks interesting. Oh, here's a good one. And just in case this is someone's problem, we'll do a little bit different. But notice here that this is giving me these conversion factors. So if the problem doesn't specifically state the conversion factors, use those ones that were posted in your announcements. If it gives you something, then just use whatever it gives you. So let's try this one. And I'm just going to change the number. And you know, we already did one that was pounds to kilograms. So let's try converting from kilograms. Say I weigh something that weighs 39 kilograms. Okay, and I want to convert to pounds. So over 1. And then I'm going to multiply, and I want to have kilograms, the units I want to change out of in the denominator, and pounds, the units I want to change to in the numerator. And then I'm going to use this multiplier. 1 pound is 0.454 kilograms. Okay, so that means that I need to cancel my kilograms. And then I'm going to have 39 divided by 0.454 pounds. Let's see what that is. I get 85.9. We're going to call it 85.9 pounds. Now, could I have also done it this way? Let's see. 39 kilograms over 1 times 2.2 pounds over 1 kilogram. So that means I have 39 times 2.2, which gives me 85.8. You can see they're just a little bit off, aren't they? Okay. Because these two are both approximations, but both pretty close, within 0.1 of one another. Let's see if we have anything else from here that looks interesting. Oh, I like this one. Convert 32 degrees Celsius to Fahrenheit. Oops. Okay, so remember we have those two versions of the formula, and since I want to convert to Fahrenheit, I'm going to use the one that has an F over here because then I can replace the C. Okay. And so I'm just going to rewrite this, and where the C is, I'm going to put that 32. And then I'm just going to use a calculator. So 9/5 times 32 plus 32. And I get 89.6 degrees Fahrenheit. And I think that's about it. So again, if you have any questions, please reach out to me or to your instructor, or consider coming to office hours or the LSC, and make sure you have that list of conversion factors for the exam.